this. So I'm gonna write down what I got, you see if you match. How does that look for the quadratic? Is that what you got? Okay, so then it says, find the residual for the year 2009. So you have a couple of options. You can go ahead and do your residual plot. And find the y coordinate for the point where x is 2 on your residual plot. Or what else can you do? You can find y of 2 and subtract that from the actual, which is 20.73. I got 1.8006. I don't know, how does that match yours? Does that look right? No? And that would be millions. All right, let me see. I'm gonna try to do this. So everybody's telling me that's not right, right?
Yeah.
Huh? Not right. So before I type it all back in again. This is quadratic.
And then trace.
You guys, I'm still getting 1.8006.
That's what we got.
Okay, all right. Let's go ahead, let's see. Find the year in which the number of iPhones is 200 million. How would we do that? Find the year in which the number of iPhones is 200 million. What would I do? That's one of my equations, and then put in 200, and may need to do a window adjustment to accommodate that. And that point of intersection. 6.34, so when did this start? So did you say sometime in 2013? 6 years after 2000, 6 points in years after 2007? All right? Okay. Now, before you do the exponential part, skip down, graph your residual plot for the quadratic. So graph your residual plot for the quadratic. Actually, I think I have it.
Oh, this certainly is. I was putting too many.
scale's a little wonky, but there you go. Okay, is that what yours looks like? Just looking at it, what do you think? Does that seem like a pretty good residual plot? Yeah, it's all right. Okay, next. What is the exponential model for the situation? Well, the good news is you already got your data in, so all you have to do is switch regressions. And I got 2.8769. 2.8663 to the x. How does that look to you? Look okay? Now, using that model, let's find what we get if x is 6. So I'm just going to do y of 6 on my calculator and see what happens. I got 389.7957, and that would be million of iPhones sold. Is that what you got? All right, now remember, in the quadratic model, approximately 6 years, it was actually a little bit more than that, but in the quadratic model, approximately 6 years, 2013, was 200 million. First of all, does that discrepancy make sense to you? Yeah, because a parabola looks like this, and an exponential looks like this, right? So it's shooting almost straight up. It's up there. All right, so do the residual plot for that one. Did your residual plot look kind of like this? With your last one way down there? Did you find out where that last one is? Where is that last one? Negative 46. That's million. What does that mean? That in the 5th year, we were already off 46 million. And since it's negative, that means your model overestimated. But isn't that what we would expect? What's happening? Those are getting really, really big, right? Too big. This is not a good residual plot because can you predict what's going to happen next? You can't? I can absolutely predict that what's going to happen after that point is it's going to be down on the floor somewhere. And they're just going to keep on going down more and more and more. So that is not a good model. It is not bad maybe at the beginning, but it gets horrible after just 5 years, 4 years, it's horrible. All right, there was a lot there. Are we good with that? Celeste says thumbs up. All right, number 21. Given all this, write an exponential with a vertical translation. Bless you. So our job is to come up with y equals a times b to the x plus c. All right, give me some thoughts. Please don't make me do all the talking. Give me some ideas here. I don't know, you guys, at this point of your life in this class, you should look at one of these and immediately start saying, okay, that's 6, that's 12, that's 24. And at this point, then you say, uh-oh, what's happening? These are proportional, right? So B is 2. So y equals a times 2 to the x plus c. Now, if you're really good and in tune, you might be able to just come up with those. I can't ever do that, so I have to do it with my algebra. So I'm going to take a point. 2 equals a times 2 to the first plus c. And 8 equals a times 2 to the second plus c. Putting in that point for x and y. So now I've got a system of equations. So 2a plus c equals 2, and 4a plus c equals 8. Did you get 3 for a? And if a is 3, then c must be 2a plus c is 2. Do you get negative 4 for c? Good? Perfect. Back page. One more page and we're done with this one. 7, 2 to the x minus 1 equals 28, 4 to the 3x. No calculator. This is a no calculator problem. So, what is your immediate thought? We need to get a common base. Would you agree with that? Yes. So let's do that. What is our common base going to be? 2? I'd use 2. Let's see, who are we missing? Valentine, Brennan. No, also who sits there? Caitlin. And William. Okay. All right, so that's already a 2, so we're okay there. This is 2 squared, so that's going to be 2 to the 6x. And we have 7, 2 to the x minus 1. Okay, now what would you like to do? Divide by 7. So 2 to the x minus 1 equals 4, 2 to the 6x. Oh my gosh, what is so wonderful about having a 4 right there? 4 is 2 squared. So 2 to the x minus 1 equals 2 squared times 2 to the 6x. How do I put these together? Those gotta go together. How do I do that? Add. So that's 2 to the x minus 1 equals 2 to the 2 plus 6x. At this point, you can set your exponents equal to each other. You can't do that until you have 2 equals 2. Then you can drop them. And it looks like 5x. Did you get 3/5?
I got negative.
Negative, that could very well be. Yep, it sure is. Thank you, Sam. Negative 3/5. 23 is almost the same thing. What do you want to do with this guy? Well, we need to come base, right? And actually, every number in the problem has a base of 3, so I'll just make that 3 to the first times, now what am I gonna do with this? 3 to the negative first. And then 3 squared. And 3 cubed to the x plus 7. So we have 3 to the first times 3 to the negative x plus 4 equals 3 squared times 3 to the 3x plus 21. Sam, that look all right to you?
Yeah. Could you divide from this?
Totally.
Okay.
Since they were all 3s, I just left them, but absolutely you could divide from the beginning. Get rid of that 3, and that would just be 3. It's all gonna come out to that. Now I'm gonna add these, right? The exponents, I mean. So I'm gonna add 3 to the negative x plus 5 equals 3 to the 3x plus 23. I add my exponents. So, Sam, we better match. Did you get negative 9/2?
No, but I might have done something wrong.
I could very well have done something wrong. Did anybody get negative 9/2? Oh.
Oh, I see what I did.
You did, okay.
It was 21, I forgot the 1.
Oh, yeah. All right, 24, simplify. 81 to the negative 3/4. Easy, no calculator. What do I do? 1 over 81 to the 3/4, which is 1 over the 4th root of 81 cubed. What's the 4th root of 81? 3 cubed, 27, 1 over 27. You should be able to do those with your eyes closed. All right, next one. 27 AB to the negative 7, 36 a squared, all to the negative 7. This is Sam and I were talking here that we had different strategies we could use. My personal verify this first. You don't have to do that. You do whatever you want, I'm gonna do that, and we'll see if we get the same answer together. You okay with that? This is what I ended up with at the end. All right, last one. 36 to the 3 kilowatts over 1/6. What do you think when you look at this problem? I think there's a couple ways you can start. It would make it pretty nice to do. What do you think when you look at it? Leslie?
I did the square root of 36 and then cubed it.
So you did the square root of 36, which is 6.
Yeah.
Cubed, you got 216?
Yeah.
Perfect.
And then I flipped the 1/6 and then squared it.
So you had 216 over 36.
Yeah. And then I simplified that to 6.
That's one way to do it. Right? Did anybody think about flipping this and squaring it? Leaving the top alone for a second. If you flip this, it's 6 to the second, which is 36. So now we have 36 to the 3 halves over 36 to the first. When I subtract those exponents, I get 36 to the 1/2, which means the square root of 36, which is 6. So that would be another approach you could use if you like. Okay? All right, so yesterday you got, or whatever that was, you got 2 review sheets. I'm gonna hand back some papers right now. While I'm doing that, you go ahead and get started on that second review sheet.
Nothing more than I've been given. Well, this usually is in my binder, but it got too heavy. No binder anymore.
What you're looking at is that other review sheet I gave you, so that you can
No, it actually, I read it. About how nerds are respected compared to other countries, like athletes, and how you can be the value of art and intelligence. You can see it. You just change it.
All of the stuff that I just have given you, you keep, all right? This I will want back.
Yeah.
All right, this pink thing I want back, okay? And I want you to look it over.
More hours worth money. It's neither doesn't cost. The more hours work, the more money you get.
I was gonna do it at lunch.
I was just thinking further today. I didn't realize it was extra. Well, it wouldn't be exponential. It'd be linear if it was. So. Maybe almost 100.
And I will be picking these pink ones back up.
That's what I'm confused on. Is it? It didn't say if it was. But I thought it can also be negative because it's like. The rate of change would be positive because the rate of change is positive. Oh, it's an increase. I got minus. Yeah, the rate of change is constant on the. It was a trick question.
All right.
Oh, I didn't even know.
Questions here in just a second.
What I get on It doesn't say round. It doesn't say round.
So does anybody have anything you want to ask about on either the paper you're working on now or the sheets that I just returned? Anything at all? Remember, we have a quiz next time I see you, Monday. We have a quiz. remember.
Oh, it actually doesn't have your part. I see it.
You sure?
Yeah.
Yeah.
No, it's your so 32.
Yeah. The one that says being adopted, more legal and all that stuff. Alright, let's look at
No,
that.
that's not big. What is last night? More people on the Netflix account. Cost of this call?
Alright, here we go. So, we were.
I literally think it's, you can have like up to 5.
Okay, so 1963 represents year 0. So 0417 would be one of my ordered pairs. And then year 56 is 71 4. That look all right? And then it says that it's geometric. So this was year 0. This was year 56, geometric sequence. So A sub n equals A sub 1 r to the n minus first would be my general formula for an arithmetic sequence. Okay, so let me just play around with this for a minute. 417 r to the 56th. If I raise this to the 56th power, because 417 is actually your 0. I think it is, because that would be m minus 1 would be 57. Yeah, so I think that's okay. I think that's all right. So I need to find out my r. So 71400 equals 417 r to the 56th. So I'm going to divide 71400 by 417 and raise it or root it, however you do it on your calculator. That's going to be r to the 56 equals 71400 to the 417. So however you do that on your calculator, you're going to root that, and that's going to give you r, which I just did at 1.096187987. That's the number we get for r. Is that what you got? So then it says, based on this model, how many nested pairs were there in the year 2000? Well, 2000, we have to figure out what that year that would be if we start with 63. So that's 37 years later, year 37. So I'm going to use basically this formula and say 417 times my r to the 37th power. I'm not going to round it off. I'm just going to take that number to the 37th times 417. And I got 12,470 if I round it off to the nearest number. What did you do differently?
Well, I think that's a good
35th?
36.
36th. Okay, so remember that this is not year 1, this is year 0. So year 1 is actually the r. So year 37 would be 37. This was to the 56th. Did you do that one to the 56th? And that was 56, because this is actually the 57th term if you start with 0. So that's why this was a 56. Okay? Well, that is exactly the year. year 56 was to the 56th power, so year 37 is gonna be to the 37th power. Year 1 would be to the first power, okay? All right, anybody else have a question about something that I didn't, yes, Celeste?
On the 2.4 homework,
Yep,
for number 2, like how would you do it? Or you just do one?
which one am I doing?
Number 2,
Number 2,
you can either do it.
okay. What are the directions? Rewrite the following. Y equals A times B to the X, and A has to be 0. So in other words, we don't want that union coefficient. So you have, like the first one is 4 to the 2X. Well, I don't have a leading coefficient, so I'm okay, but I also don't have an X. So I'm gonna break that apart, split it, and think of it as 16 to the X. And then the other one would be exactly the same thing. This is 1 over 81, so that would be 1 over 81 to the X. You can only do that because these exponents were multiplied. All right, anything else?
So for the same one for 3, you got
This problem,
yeah,
number 3,
I got the same answer, but I did it different. Like I did it wrong.
like for 3A,
On the pink sheet.
or on the pink sheet. For which one? Isn't that the one we just did?
Yeah, but I got the same answer, but I did it wrong.
What do you mean you did it wrong? I'll look at it afterwards, okay? Yep, Charlie?
On the review sheet that we didn't do C, I just wanna understand why, like,
Wait, the one we did do or the one you're
how
working on
we
right now?
working on right now.
Let me find it. I don't think I can fix it. Which one is it, Charlie?
It's C.
C. A swimmer wants to qualify for the Olympics is planning to reduce his time by 3% each week of the summer. Do the swim times for each week of the summer represent an arithmetic sequence?
I said maybe no.
There's no maybe about it. If you're decreasing by 3%, then, okay, so let's say he swam, or, his first time, I'm making up numbers, I can work, 100 minutes, okay? If he decreases by 30%, or by 3%, then his next time is gonna be 97, and his next time is gonna be 97% of 97, which is 94.09. Now, this went down by 3, this went down by 2.91,
Yeah, okay, I
and the
see.
next one's gonna be down. See,
Yeah.
any kind of percentage is involved, it's geometric,
Alright.
not arithmetic. All right, we're almost out of time. I'm gonna come out and collect those pink ones. You can keep all the rest of them. Is there anything else that you have a question about? Here. Just need a This is the rate of change. That's the question. 2 more minutes. Any last, I think 2 more minutes. Any last minute, all right, that